Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to continue one more problem on definite integration. Let us start with problem number 10. Integral 0 to pi by 2 sin x into cos x dx upon cos square x plus 3 cos x plus 2. Here friends, in the denominator you can see we have a quadratic expression in terms of cos x. Therefore we need to substitute cos x first as t, but make sure that its derivative is present in numerator or not. As you can see, the derivative of cos x will give you minus sin x. That minus sign can be adjusted, but sin x is important, and that sin x is already present in the numerator. So let us substitute cos x is equal to t, and first find the new limits. The previous limits of x are 0 and pi by 2. If I put x as 0, cos 0 will be 1, and if I put x as pi by 2, cos pi by 2 will be 0. Therefore the new limits are 1 and 0. Further, we need to differentiate this equation with respect to t. This will give you minus sin x dx is equal to dt. That is, sin x dx will be minus dt. Now let us see the integral. We have lower limit as 1, upper limit as 0. Sin x dx we have minus dt. Cos x is t. We have cos square x, that will be t square, plus 3 cos x, that is 3t, plus 2. Taking this minus sign outside, we have minus integral 1 to 0 t dt upon t square plus 3t. Now remember friends, whenever you have a minus sign outside the integral or a negative sign which is present in the integral, you can eliminate that minus sign by directly replacing these limits. That means if I need to eliminate this minus sign, our previous limits, that is 1 to 0, can be directly written as 0 to 1 t dt upon t square plus 3t plus 2. This property can be written as minus integral a to b f of x dx can be also written as integral b to a f of x dx. As you can see, we have eliminated minus sign and we have interchanged the position of their limits. Further, we can factorize the denominator as t square plus 3t plus 2. We need plus 2. The two factors will be 2 and 1. 2 into 1 will give you 2 and 2 plus 1 will give you 3. In this case, both will be positive. Therefore, we have t square plus 2t plus 1t plus 2. Taking t common, we have t plus 2 left from the first two terms. From the last two terms we have plus 1 common, and again we have t plus 2. Therefore this can be written as t plus 2 into t plus 1. We have I is equal to integral 0 to 1 t dt upon this quadratic expression. We are going to write it as t plus 2 into t plus 1. Now you can clearly identify this integration. Here we have the rational form and we are going to use partial fraction integration method. Now the given rational form is t upon t plus 2 into t plus 1. We have two constants, a divided by t plus 2 plus b divided by t plus 1. Let us multiply by this denominator on both sides. Therefore, in the left hand side we have numerator, that is t. On the right hand side with a, the missing term is t plus 1, and with b we have t plus 2. Now we know how to find the values of a and b. To find a, we will make this first bracket as 0. To make this 0, we need to put t as minus 2. Put t is equal to minus 2. This will give you minus 2, that is the value of t, as a into minus 2 plus 1 plus the remaining part is 0. On further solving, minus 2 plus 1 will give you minus 1, and minus 1 into a is minus a. Minus will be cancelled, and therefore the value of a is equal to 2. Similarly, to find the value of b, we can make this bracket 0 by substituting t as minus 1. As minus 1 plus 1 will become 0. So we have t as minus 1. This part is 0 plus b into minus 1 plus 2. Now we know that minus 1 plus 2 is plus 1, and 1 into b is b. Therefore, the value of b is minus 1. Now, instead of integrating this part, we will integrate the second part. Therefore, I is equal to integral 0 to 1. We have a upon t plus 2, and the value of a is 2. Therefore, it is 2 upon t plus 2 plus b upon t plus 1. The value of b is minus 1. So, it is minus 1 upon t plus 1 dt. Now, let us separate the integration. Therefore, I is equal to integral 0 to 1, 2 upon t plus 2 dt, plus into minus will give you minus, integral 0 to 1, we have 1 upon t plus 1 dt. Now taking these two constant outside the integral, we have 2 integral 0 to 1, 1 upon t plus 2 dt, minus 0 to 1, 1 upon t plus 1 dt. Therefore, I is equal to 2. We know it is a linear equation, therefore 1 upon t plus 2, its integration will be log of t plus 2, minus, here it will be log of t plus 1. Both are within intervals or limits, you can say 0 to 1. Now let us substitute these limits. This will give you 2. We have log of 1 plus 2 minus log of 0 plus 2. Just substitute t as 1 and 0. Minus log of 1 plus 1 minus log of 0 plus 1. This will give you 2. Log 3 minus log 2, followed by minus, we have log 2 minus log 1. I will be, as we know, log a minus log b will give you log a by b, that is log 3 by 2, minus, further we have log 2 and log 1 is 0. So minus into minus we have plus, log 1 will be 0. Now to further simplify, we can use the property m log a, as m log a can be written as log a raised to m. Similarly, this will give you log of 3 by 2 the whole raised to 2. Therefore, I is equal to log of 3 by 2 square minus log 2, that is equal to log of 9 by 4 minus log 2. Now again we can use the formula log a minus log b, that will give you log of a by b. Now this b will be multiplied in the denominator. Therefore, I will be log of 9 by 8. This is the final answer. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.